Hola, it's Smikket here. Let's learn about integer exponents. What are they and what kind of properties / characteristics do they have? Well, I'm going to show you. So when we're dealing with integer exponents, we're going to start off with what we call our base. I'm going to call it a, just to teach you guys the concept. And a can be any positive integer. So anything from 1 all the way up to infinity. You can pick whatever number you want. Okay, and then we're also going to have what we call an exponent. And for the exponent, I'm just going to write n up here. Okay, so if we have some integer a to the power of n, as we call it, what that's going to be is a times a times a times a, and so forth. And we're pretty much going to multiply a by itself whatever number of times n is. Okay, so if you kind of get it, but not all the way, let me go ahead and show you some examples with real numbers. So if instead of a, I wrote 2, instead of n, I put a 3 as the exponent, what this is going to equal is 2 times 2 times 2. And that is the most basic idea of what this exponent is doing. And you remember, we can use any real numbers, guys, for the a. And then for n, we can use whatever number we want. Any negative number, any sort of negative fraction, positive fraction, decimal, 0 even, really any number that you want, guys. Okay, so I'm just going to elaborate on this a little bit more. 2 to the 4th power equals 2 times 2 times 2 times 2. And if I went ahead and made this 5, okay, so 2 to the 5th power is going to be 2 times 2 times 2 times 2 times 2. 2 by itself 5 times. So hopefully that makes sense to you guys. Let's go ahead and look at a few more rules. Okay, and so the 2 rules that we need to go over real fast is that if we have a to the 0th power, whatever a is, if it's to the power of 0, it's always going to equal 1. So I'm going to quickly go ahead and paste in some examples for you guys of that rule. Okay, negative 3 with the power of 0, it's going to equal 1. If we have 4 as our base and 0 as our exponent, it's going to be 1. If we have 5,232,400 to the power of 0, guess what? It equals 0. Alright guys, so just remember that rule. It'll definitely show up down the road. Let's go ahead and move on to the next one. So if we have a negative exponent, what you're always going to do is take this whole thing, turn the exponent positive, and put it over 1. Okay, so we're just flipping it and turning the exponent positive. So I'll go ahead and do the same thing and paste in a few examples. This one is pretty straightforward, so I won't take too long on it. So if we have a base of 3 and an exponent that is negative 2, what we're going to do is draw 1 and then stick this guy under here. 1 over 3 to the positive 2. And I'm sure you guys can see that that equals 1/9, which that's not really the point, but you get it. Okay, next example. We've got 6 to the power of negative 8. Okay, that's going to equal, you guessed it, it's going to be 1 over 6 to the power of 8. Okay guys, so like I said, remember those rules, they're important. Okay guys, so let's move on to the properties or the characteristics of exponents. Okay, so these 5 guys right here are our properties of exponents. Let's start with the product rule. This is basically what we do when we multiply 2 different numbers that both have exponents. Well, actually, 2 of the same numbers that both have different exponents. So, if we had a to the power of, we'll call this m, times a to the power of another n, we're going to get a to the m plus n. Okay? So let's use some real numbers just as an example. So for a, I'll have 3. M is going to equal 7 times 3, and we'll have n equal 2. So if you came across a problem like this, what you're going to do is just keep that 3, 7 plus 2, which is going to equal 3 to the power of 9, which 3 times itself 9 times is a pretty big number. I'm just going to leave it like that. Okay guys, so let's go on to the quotient rule. Okay, so this right here is the quotient rule. It's very similar to the product rule, except instead of multiplying these two things, we're dividing them. Okay, and so when we're dividing, instead of adding m and n, we're going to subtract. Okay, so let's look at an example with real numbers. If I had 3, 2, over 3 to the 7th, that's going to equal 3 to the 7th minus 2. Or I apologize, it'll be the other way around. Let me fix that. Okay, that's going to be right. It's going to be 3 to the power of 2 minus 7. Okay, in this case we used 2 as our m, we used 7 as our n, and 3 as our a. And that equaled out to 3 to the power of 2 minus 7. Alright, let's move on to the power rule. Okay, so if we had a to the power of m, and we put that to another power of n, what we're going to get is a to the power of m times n. Okay, so if I did 3 to the power of 7 to the power of 2, what are we going to do? Easy fix, guys. We're going to do 3 to the power of 7 times 2, which will just equal 3 to the power of 14. Okay, so that's all you need to know for the power rule. The product to power rule is a little bit different. Okay, so with the product to power rule, inside of these parentheses right here, we have a times b. That's going to be what we call a product. Okay, and then we're just putting that to a power. A times b in parentheses to the power of n. That's going to equal a to the n times b to the n. Okay, so all we're doing is distributing that exponent n out to these guys. So let's plug in some real numbers so we can definitely see how this works. Alright, so I'm going to put in 3 for a, 2 for b, and our exponent n is going to equal 4. And this is going to equal 3 to the power of 4 times 2 to the power of 4. Okay guys, and I'm going to plug this into my calculator real quick and I'll tell you what that is. Alright, so I believe that's going to equal 97. Alright, one more thing, the quotient to power rule. Alright guys, very, very similar to the product to power rule, except instead of multiplying, we are dividing. And just a quick note, b cannot equal 0 because then we'd be dividing by 0. Anyways guys, so let's plug in some real numbers for this guy. 3 over 2 to the power of 7 equals 3 to the 7th over 2 to the 7th. And I will plug this in and give you guys a value one more time. Okay, so I went ahead and did that, and I got 17.08. Alright, there you go. That is all I have for you guys today. Thanks for watching. Like and subscribe if you enjoy these videos. It'll really help me keep on going. Alright, guys. Have a great day.